Find the power series for the function with the given center A and identify its interval of convergence. So now let's take a look at this one here. Now the idea here is I have to make this look like 1 over 1 minus x, or as close as I can to that, so I can use that power series that I know that it equals, which is this here. So this is the idea we want to use here. So we can see that they're close, but they're not exact. So we want to try to get it in that form as much as we can. All right, so let's get started. This one here also has another component to it that we haven't seen yet. This is an A equals 1. So we're going to be centered at 1 here. So the idea then is, okay, so I'm going to start. I have a 1 on top, so that's there already. And I need to be centered at 1, so I need an x minus 1 here, because that's going to be centered at 1. Because I look at this and say, hey, what makes that 0? A positive 1 does, so I'm centered at 1. And I also need a minus here. So now I'm going to do is just find out what number needs to be here so that these two pieces here are equal. Okay, so now what I'm going to do is it's actually a 1. And I'll show you why. Okay, because if I do a 1 and I distribute this negative through, that's going to be a minus x plus 1. And this actually equals 2 minus x. So this one actually works out really nice this way. And most of them will, if I can catch on what to actually do. Okay, so that really is the function that I'm going to use in this form here. And the reason why that is, this is really, when I think of that form now, this is my 1 that matches, this is my 1 that matches, and this right here is going to be the piece that x was. So that's what I'm going to do now. All right, so I know the power series, and I'm just going to write the one I know already. N equals 0 to infinity of x to the n, and we know that equals 1 over 1 minus x. So the series we want is going to be x minus 1, because that's what we subbed in for, x here. And then that's going to be to the n. So that's going to also go in for that x, and that's why we do it. Okay, so now we know that's going to give us that 1 minus x minus 1, which equals the 1 over 2 minus x. And I kind of showed you that already. So our answer then for this, we did find the representation. The answer I would write for this is the series n equals 0 to infinity of x minus 1 to the n. Now again, you have to show work for this, so you can't just write the answer down and say, oh, I get my full credit. I don't really just care about the answer itself, but all the work I have before it supports the answer I came up with. So it's important that you write all your information out like this. And then another thing is, as we go through these, don't just think, oh, I know the answer and that's it. So just be careful with that. Okay, the next part we're going to do now is we're going to find its interval of convergence. Okay, so let's do that now. So again, what do I think of when I think of finding the interval of convergence? Ratio test. There it is. So I just started it out because I'm always writing this, at least for these problems, as n goes to infinity. And an plus 1 is just really x minus 1 to the n plus 1 over x minus 1 to the n. And I'm just going to keep writing these and breaking them down. So if this is a problem for you, you can fast forward through. And then I see that these are going to cancel out. So this is really the limit as n goes to infinity of x minus 1. Now remember, our variable here that we're taking the limit of is n. And we don't have any n's here, so that tells us that we're going to end up with just that x minus 1. Now again, it's the absolute value of that, and it has to be less than 1. So I think about my compound inequality here. So really what I have is -1, and then I have an x minus 1 here, and that's going to be less than 1. So my x minus 1 is going to be between -1 and 1. Okay, so now what I'm going to do is just add 1 to all three sides. And that's how we work with these compound inequalities like this. We just do it all together. So then this is going to be 0, and now this is x, and now this is 2. So I'm just going to kind of show you what happened here. I think of these in my mind like a number line. All right, so this is kind of what I have. I was originally between -1 and 1. And then what happened is, because I'm centered at 1 now, I'm going to change. So that means I'm going to shift over. And I preserve the distance. So now I'm going from 0 to 2. In my mind, that's what I see. So this 1, 1 is just going to move over. And from this, I can also easily see that if I had to do the radius of convergence, my r would equal 1. Because remember, it's always from the center to the side. And that's how it works with a radius on an interval. Okay, but anyways, let's get back to our problem. So now I still have to test the endpoints here. So I will have to talk about 0, and I will have to talk about 2. And essentially, I'm going to plug those in for x into my series here. And then look at those series and determine if they're convergent or divergent. So now, let's move on. So now we got to test these end values. So I'm going to plug in 0 for x. So that's really just going to be 0 minus 1 to the n. And that really just equals n equals 0 to infinity of -1 to the n. So now I can simply use the divergence test here because the limit, and I just take the, as n goes to infinity of -1, I just take the sequence that I'm summing up in that series there. And then I just take that as n goes to infinity. And I see easily that this is going to be alternating from -1 to +1, so I can say d and e does not exist. So that implies by the divergence test that the series n equals 0 to infinity of -1 to the n diverges. All right, and then similarly, I'm just going to do the other one now. N equals 0 to infinity. And I'm just going to plug the 2 in and just do the math kind of on the fly for this one. So when I plug in a 2 there, that's going to be 1. So this is going to be 1 to the n. So when I look at that series as n equals 0 to infinity of 1 to the n, this is just going to continue to be 1 as I take that limit. So again, I'm going to use a divergence test here. So I'm going to take the limit of the a sub n, which is 1 to the n as n goes to infinity, and that's going to equal 1. And again, it's not 0, so that implies by the divergence test that the series n equals 0 to infinity of 1 to the n diverges. So then I can say the interval of convergence is 0 to 2. There's my final.